introduce myself. My name is Birkin, and I think that's all you need to know about me. Yeah. So why are you looking at Tokudb? Perhaps it's something that your data is growing too fast, or you have a requirement for some sort of high volume insert, or you have some requirement for cost accounting for making sure that your hardware will still make it for a longer time, right? Or perhaps you just think it's shiny. Right? You've read somewhere or you've listened somewhere that all of the features that Tokudb is advertising is shiny, and you just want to put it out there and put it on production. But again, you have to evaluate it properly to make sure that it will work for you and not against you. And the shiny Tokudb features that you might have otherwise read already is about, you have a lot of compression choices, you have fast, you have quick, you have some high degree of compression like LZMA or snapping. You are able to do hot schema changes, which is very good, and Tokudb enables that because of its internal working, and like using the free fractal tree uses message buffers, so you don't have to do everything in real time. Amortized writes, and message buffers for Tokudb, its fractal tree works well so that you can amortize writes more, and it can merge writes instead of doing much more random IOs. I'm not gonna talk, longer than I can, because all of this is documented. I just want to share, what is important when trying to use Tokudb. Oh, sorry. Longer hardware write because of the amortized writes. If you're using SSD or if you're using flash drives, then because you're saving all of those IOs, you're reducing the wear and tear of your flashing hardware. And faster replication. There's a feature with Tokudb that you can do read-free replication, and it relies on row-based replication and having the slave server read-only. Because with row-based replication, Tokudb can rely on the full image of the binary log event without, and it does not need to read from disk or from memory to apply that event into the row. And there's also multiple clustering indexes, which of course you have to know what you're doing before actually implementing multiple clustering indexes. You can otherwise just overshoot your compression goal, and instead of saving space, you're actually using much more space than you have planned. But beyond these features, it might also be because you need to get past InnoDB limitations. Again, as I mentioned earlier, some things like InnoDB has a limit on how far it can compress or how far it can accept writes and things like that. And you are willing to compromise between a few things you lose when moving away from InnoDB, like its excellent OLTP capabilities, mature optimizations including backup solutions, and you are bent on evaluating Tokudb, right? So the first three things that you would need to focus on when evaluating any technology, or in this case Tokudb, are your queries, your overall performance, and the requirements on running Tokudb in production successfully. I believe these things, and queries, overall performance and requirements for both hardware and software are the very, very basic things before actually touching or even downloading the binaries and then getting your hands dirty with Tokudb. First, when evaluating your queries, I think when I was working with users, the first questions that they would usually ask me is, do they need for rewrites, right? When looking at the queries, it is always prudent to ask ourselves, whatever engine you're trying to migrate to, it's always prudent to ask ourselves, do we need to actually rewrite anything? right? In many cases, you don't need to, but in Tokudb, there are some cases where if you are looking for that specific feature of that is being offered by Tokudb, there are some rewrites that you need. For example, when you are doing optimize or doing regular changes on the schema, then there are certain things that you can and you cannot do with Tokudb tables. Grammatical changes, there are. Again, if you're targeting specific Tokudb features like optimize or when you're adding clustering keys, that is most important, because if you're using clustering keys, there are different syntaxes when using Lacuna Server or MariaDB, because MariaDB uses key attributes. In terms of performance, there are actually good and bad trade-offs that you do need to watch out for. First, the bad things are unique key and non-sequential primary keys are very bad, right? When you're using unique key, it actually translates into read and read from either the message buffers or from this, and then write, right? So it's an additional work for Tokudb. Also, non-sequential PK is not very good because it can result on a very bad fragmentation in in-memory workloads. Selects also suffer from penalties because in the fractal tree, in the internal working of Tokudb trees, message buffers are used to amortize that write to the leaf nodes, right? And when you do select any row that have messages in that tree, then from the root to the leaf, you have to merge all of that. And if you have a very high tree, then you get that additional overhead of reading. The key good things are amortized writes, as I mentioned earlier. White tables, many indexes, still you have good write performance. In some cases, it's actually comparable to, from having one index and having 1,000 indexes or having 1,000 rows, you'd have the same performance in terms of writes. And read-through replication. There are more, I just wanted to highlight the key things here. Now, for a minimum install, it is always required to have transparent huge pages enabled, and I would also recommend tuning the number of open files for MySQL. For transparent huge pages, because Tokudb is using large block sizes of 4 MB, it can result to more fragmentation, like when you're using InnoDB. So you have to disable transparent huge pages, and at the same time, it's because using JML, right? There's a really good blog post from Peter that explains why Tokudb really does not want transparent huge pages, and I think it's the same thing with Redis and Couchbase. For the number of open files, Tokudb have some specific characteristics when handling file descriptors, right? The first thing is, if you have partition tables, when you open that table, all of the partition files are open. And with Tokudb, you have a separate file for indexes, a separate file for the primary key, a separate file for a status file that contains information like the max auto increment or the columns and things like that. So if you have like a very big partition table and which have 1,000 files in it, when you open that, then you have 1,000 file descriptors open. And if you have a large number of tables of the same size, then you can easily run out of open file descriptors. The other thing about open file descriptors here is when you're having or running a number of concurrent Tokudb bulk loads, it generates temporary files. During my test, I was loading 1 billion rows into a table. It generated like 3,000 temporary files, although at peak, the only file descriptors that were used during this test were about 172. There are certain logic on how many files from this list of temporary files are being used. And I think it comes to merging or in-memory sorting of these temporary files before writing them into the Tokudb files. For the minimum MySQL configuration, as I mentioned, it's open files limit, number one. Tokudb FS reserve %. This is because by default, it uses 5% of your file system. And if you have like 2 terabyte, that means 100 gig. So if you, 100 gig is, let's raise that a little more. If you have 10 terabyte, then that's probably 500 gig, right? And when you're running out of disk, Tokudb actually doubles that before halting anything that you can do on your Tokudb tables. So you're wasting a terabyte of disk that otherwise can be used for something else before affecting your service. So this is something that you need to tune beforehand before running Tokudb, or otherwise you need to restart to change this. Tokudb cache size is 50% by default, right? And in some cases, even though you have been very prudent on tuning your memory configuration, Tokudb has this behavior of overshooting your memory consumption anyway. There's a bug open for that even though you have set a limited amount of memory for Tokudb cache size, you'd still consuming double or even more than that. And one thing you can do about Tokudb cache size here is to use C groups in Linux so that you're actually putting a wall on the actual memory usage of MySQL. Tokudb Direct IO on is when you have, or when you want to make sure that your writes are actually getting to disk. But in some situations, if you're looking for performance, setting this off is much better. When you're using C groups to limit your memory usage, and having the OS file system cache to cache the other files of the other parts of the Tokudb tables, then it can improve performance much more. The last one is binary logs. You have to make sure that binary logs are enabled, especially if you're mixing InnoDB and Tokudb transactions. Why? Because when you do that, the two-phase Tokudb uses two-phase commit, and it uses the binary log to make sure that those transactions are in sync, right? And let me show you just an image. This is when you have binary logs enabled, and this is when you have binary logs disabled. And that is what kind of performance, because when binary logs are disabled, it uses the transaction controller log, and it does a lot of fsyncs, and it really trashes your I/O. So you really would want to have the binary logs enabled. Another benefit of having your binary logs enabled is taking advantage of binary log group commit. So in some situations, Tokudb can take advantage of that. And of course, lastly, your malloc library should be JMalloc as a standard. When loading data, you don't want alter table InnoDB to enter Tokudb. That would be very slow. You don't also want to import an SQL file to a Tokudb table. That would still be very slow. You'd want a select into out file if you have an existing InnoDB table. Select that into out file to a CSV and load that back into from out file. That is much faster. I tested it on a 1 billion table. I can do select into out file and load data in 6 hours. But when using alter table, 6 hours passed, and it's like 25% of progress. And the import one, it took, I'm not sure, I forgot the graph, but it's more than 7 hours at least. Backups, there's a backup plugin for Tokudb, and it's Tokudb Hot Backup. It can take consistent backups of your Tokudb tables, but there are catches to that. It copies everything. So if you have alien files on your data directory, your temp directory, your log directory, for example, large compressed files that you accidentally kept on those directories, they would also be copied. So if they're larger than your data, then you're wasting backup disk. It also only recognizes files from these 4 directories. If you have set them custom aside from the data directory, then it will only recognize files from this. And if you have your binary logs on a different directory, then your binary logs will not be backed up, right? And the binary log backup is very important with Tokudb because of recovery. Also, when you're using EnowDB, make sure to disable native AIL within EnowDB. Otherwise, it can be including cost corruption. Look for the bug on Launchpad, and you'll understand why. If you're using the standard configuration, you have everything on a single folder, use LVM for backups, or MyDumper in that case. I cannot suggest anything more aside from hacking my LVM backup to, if you have your binary logs on a different server or in a different volume. Last, okay. What to monitor? I think this is the last one. Okay. What to monitor? Again, open file descriptors. If you have a certain limit of open file descriptors, make sure you have it monitored. Swapping is very important as well, because again, Tokudb, if you're not limiting the memory usage in C groups, or your data set size is growing too fast, then you have to make sure that you're watching out for swapping, because Tokudb is normally an IO-bound workload, and if you swap and you combine that with an IO-bound workload, then it's really, really bad. Checkpoint durations. In some situations when the workload is very heavy, IO heavy, your checkpoint can last for the default of 60 seconds, and when that happens, when the next checkpoint runs, it'll be stopped and another checkpoint will run, and it'll be just like trashing your whole IO. Some things you can do is like disabling commit sync to reduce the amount of IO, or reducing the frequency of reducing the checkpoint interval, right, from 60 to something smaller. Yep, those are the basic things to monitor for Tokudb. Of course, on top of the normal MySQL variables that you would otherwise want to watch out for, and make sure it is healthy. So, questions? Okay, that was not too fast. Yes, sir.
To import the database from MySQL, for example, to Tokudb, is there anything we need to be careful about, or does that work seamlessly with the out file that you?
Yeah, for that, I think you just have to watch out for what the normal things that you would otherwise watch out for when you're migrating from server to server, or just the things that you would regularly look into. Yes.
About the false replication, you were saying it was not reading from memory, and what was the thing why it was faster in replication?
Read-free replication.
Yeah.
Yep. So it uses the whole image of the binary log event. So it can change, and it can include that information on the message buffers without reading from the message buffer from the whole tree, right? So you have the before and after, and it can just use that to write a message that can go down to the leaf node, and that is enough to have a consistent image of your own. Yeah. Yep.
In the past, it used to, for the fast load data to work, it needs to be from an empty table. Is this limitation lift, or is it still there?
It is still in fact, yeah. Yes, so for the there's an optimization when you're bulk loading into Tokudb tables. When it's empty, it'll be very very fast. But when you have a non-empty table with active transactions, it can be very slow, right? Because when it's empty, Tokudb can exclusively lock that table and have everything dedicated to that process. But there's a variable called Tokudb prelock empty that even if you have the table empty and you have that disabled, it'll still be slow. So I think the default is enabled, and you have to make sure that you take that optimization. Yep.
About fragmentation, it tends to diffract the table naturally when you insert because of fractal tree. What level of fragmentation do you still get inserted that you need to master?
The only fragmentation, the only real problem in terms of fragmentation is when you have too many messages that are not flushed to the leaf nodes. If this happens, then even selects can be affected. The way you can do is rebuild the table and have the messages up, or optimize the table so have all of those messages merged to the leaf nodes. Those are the things that I've tried. Haven't tried any other options as of now.
There's some cleanup thread too normally that
Yeah.
should move the message buffers down. But
Really?
Yeah.
Yeah, I've seen that it happens a lot with non-unified insert distribution. If you wave inserts a lot, you do some kind of range of priority, for example, and then you start at some point inserting to very small some point in the data where there was less inserts, for example, at some time, then it becomes
As I mentioned earlier, the problem with defragmentation is the only defragmentation problem that I'm aware of is you have data scattered messages within the tree. So if you have all of the messages up high on the higher levels of the tree, then it's not a very big problem. If you have everything at bottom or close nodes, then it's not also a problem. But if you have it scattered, then it